Hello. So today we will discuss sorting using binary search tree. In previous lecture, we discussed about sorting using heap structure, which was a balanced binary tree. Now, now I'm going to discuss the sorting using binary search tree. So what is the difference? First, I will tell the difference between binary search tree and tree so that it will be clear the sorting technique, how it differs from binary search tree and heap search technique. So in his sort, we use the heap structure, which is actually known as balanced binary trees. Why it is called to balanced binary tree? That unlike binary search tree where nodes can be inserted at any level, maybe the previous level is not heard, but still there is no limit how long the left subtree and right subtree will go, depending on the insertion of node. But in case of heap, it is always fixed that in a particular, suppose when a new node is inserted, only then the current maximum level, if it is not exhausted, then the new node will be inserted into the maximum level. If the maximum level becomes exhausted, then only the new node goes to be inserted in the next level. So this is the difference between heap sort and binary search tree. That in case of heap, the tree becomes balanced because until the most previous level is not totally exhausted, the insertion will not be happening at the next level of the tree. But in case of binary search tree, it is not like that. A new node is inserted at any level. Maybe the maximum highest level is not inserted fully still. The new node insertion can take place as the new level of as well. So that in that case there is no limit. What will be the size of the left subtree and what will be the size of the right subtree? It is not balanced at all. So this is the difference between binary search tree and heap. Heap structure is maintained such that it becomes balanced, but in binary search tree, it is not a balanced one because left subtree can go to so much higher level where maybe the right subtree is empty. But one similarity is that both binary search trees and heap tree both are binary tree only. That can say both have at most two children. One is left children and another is right children. So today we will discuss about the binary sorting technique using binary search tree. Now this is clear what is the difference, that means, and what is the similarity between heap and binary search tree. But now we will discuss about what is binary search tree. Binary search tree is like that the left subtree of left child of the root node, the value of the left child will be always made back the root, and the value of the right child will be always greater or equal than the value of the root. So if we go to the left subtree of the root node, then all the nodes in the left subtree have value less than the root node. And if we go to right subtree of the root node, then all of the nodes in the right subtree will have higher or equal values than the root node. So that is the characteristics of binary search tree. But and on the contrast, if we discuss the characteristics of the sheaf, it is that the in root node will always have more values, greater values than either or both of its children. So in that case, root node always gives the maximum value between its left than its left and right children. But binary search tree, the root node will be in the mixed position. That means the left subtree, the all nodes in the left subtree will contain the less values than the rows, and all the nodes in the right subtree will contain equal or higher values than the root node. So that is the difference between characteristics between binary search tree and tree. Now I will discuss that how to do the sorting using binary search tree. So first of all, why I'm discussing about tree, because then it will be clear why this different kind of tree structures are used for sorting. The fixes become different in its sort. If we just own the root node as the highest value among all of its children, so if we construct a head root node, will get the highest value among all other nodes. Again, that node, if we exclude that node and construct a heap about of remaining nodes of that heap, then again the root node of that remaining nodes will contain the highest value. So in this way, we find out the nodes in ascending or descending order. If it is a mass seed, so we will get in ascending order, we will get to the array. And if it is mean here, then we will get to the array. It is stored, actually this is stored in one dimensional array. And if we create the min here, then we will get the array in descending order. So, but in binary search tree, the technique is that if we are not that every node is of type structure. Structure means in a structure means there will be three fields into one structure. One pointer will be that which will point to the left children, and another right children will contain the address or the index of the right children. If I'm using a pointer to implement a binary search tree, then left and right, these two values in the structure will contain pointers, where the left will point to the